These test engineers are checking out a sophisticated collection of telescopes, gyroscopes, and electronics for Project Apollo. This guidance and navigation system will be mounted in an Apollo spacecraft to aid our 3 astronauts on their voyage to the moon and return. The miniaturized computer at the very heart of this system is our story today on Science Reporter. Today, we're at the MIT Instrumentation Laboratory, which has been given design responsibility for this guidance and navigation system, which will direct our Apollo spacecraft on the way to the moon and back. But today, we speak of traversing 1 million miles of empty space, where there is no north nor south, no rising nor setting sun, not even any up or down. It's an extremely complicated task requiring many, many measurements and millions of calculations. As you can see from this Apollo flight plan, there are several critical maneuvers that have to be performed. Someone has compared it to shooting at a moving target from a revolving platform which is mounted on a train which is going around a curve.
One of the interesting aspects of the guidance system is the way in which the astronaut controls the guidance equipment through the computer. And he does so by means of the display and keyboard, which is a subsystem. An example of it might be a verb 16, which is continuous display in decimal, and a noun, which is time. I picked these. I know it worked. I've now told the computer what I want, but I have not yet told it to go ahead and do what I want. When I press enter, the computer proceeds to display time, and it does so, giving me times from launch, perhaps, in hours and hundreds of hours, 98.56 hours from launch.
In the final phase of the screening and burn-in process, the girl puts the parts, as she's doing here, into a test socket. Then those parts are placed on this burn-in rack. After we've ensured that we have good components, then we want to make a module. Now, the little cans here are placed in these holes in a component holder. Mm-hmm. Then we take a matrix, which is a complex wiring pattern. It's placed on the back, and the wires are folded over and welded to the leads of the micrologic unit itself. I'd like to show you now how we make a matrix. In the final operation, this girl uses a cutting tool to remove the excess pieces of wire to give us the final configuration of our precise wiring pattern.
This matrix, then, is the wiring that sort of connects one little microelectronic circuit to another.
That's right, John. This wiring diagram shows you how the matrix can be used to interconnect the micrologic elements. See here, a wire will run from
Began the lunar landscape, gliding over craters and craggy mountains. You approach the target area and begin searching for a level spot to land. What this spacecraft looks like and how it operates is our story today on Science Reporter. Hello, I'm John Fitch, MIT Science Reporter. I'm standing on the floor of plant number 5 at the Grumman Aircraft Engineering Corporation in Bethpage, New York. This is a company perhaps best known for its long history in building military aircraft, from the stubby-winged torpedo bombers of World War II to the latest supersonic fighters. But this company has also received a contract from the National Aeronautics and Space Administration to develop and build the Lunar Excursion Module, or LEM. This is the spacecraft which will carry 2 astronauts from a lunar orbit to the surface of the moon and back up again. In a moment, we'll have a chance to climb aboard the LEM and actually make a simulated landing. But first, let's see how this spacecraft fits into the overall Project Apollo mission to place man on the moon and return him safely to Earth.
The adapter mounts the LEM to the Saturn booster vehicle.
All right.
Now, after the adapter is jettisoned, all 4 legs will be deployed by means of a spring-loaded mechanism. Now, I can demonstrate the deployment of this one leg right here. I'll release this demonstration pin, and the spring-loaded mechanism will deploy the gear. In the actual case, this pin release is performed by an explosive device. over here we have the scientific equipment bay. This houses some of the typical experiments that the astronauts will conduct after they land on the lunar surface. We can remove the panel here and show some of the representative equipment.
I mean, the astronauts would get down out of the spacecraft, come around here, and take out these pieces of equipment?
These boxes are removable, and depending on what experiment they were conducting, they would take the boxes out and lower them down to the surface.
Well, now, what sort of experiments would they perform?
Well, some of the typical scientific experiments would involve seismological measurements, looking for moonquakes on the lunar surface, measurements of the lunar atmosphere.
Oh, really? I didn't think there was any atmosphere on the moon.
There is calculated to be a very tenuous atmosphere on the lunar surface. In addition, the gravitational and magnetic fields would be checked with this equipment. These boxes here are concerned with geological measurements in which we would analyze specimens right on the lunar surface, and in addition, take specimens back with us in sealed containers, return them to Earth for further examination.
I noticed this panel over here says something about a TV camera.
Yes, we can look inside this one. This houses the cables for various antennae that we set up on the surface, and also the TV camera, the portable TV camera that the astronauts will carry with them out onto the lunar surface.
Does that mean that people on Earth will actually be able to see what's going on with this?
They will see real-time television transmission of the activities on the lunar surface. These cables will be connected to antenna and to the handheld TV camera, respectively.
That is going to be a very exciting event.
It sure will be.
Developing the lunar excursion module. Is that so you can see whether the controls will actually allow you to fly it properly?
Yes, right.
But this room doesn't move, does it?
No, it doesn't. It's a fixed base simulation. The cockpit we're standing in doesn't move. The displays do move, however, these internal displays here, and also our external display, which is a TV monitor.
Well, what do you see on that?
You see the motion of the vehicle. I'll tell you how it works. The pilot stands in the flight station, and he moves the controls and works through a computer, which is an analog computer in another room, which in turn flies a television camera over a lunar map, which is in another room.
Oh, and then you see the output of that camera here.
Yes.
So that as you move it looks like you're lighting
the camera.
Is it very realistic?
It's realistic, yes. It's a 6 degree of freedom simulation. Now, we accurately represent pitch, roll, and yaw of the vehicle about its 3 axes, and also translation along these axes, in other words, up, down.
Although the simulator we've just seen is firmly rooted to the ground, engineers at NASA's Langley Research Center in Hampton, Virginia, have built a LEM simulator which actually flies. This is the Lunar Landing Research Facility, developed to study techniques for landing LEM on the moon. This gantry structure is 250 feet high and 400 feet long. An overhead crane simulates the reduced gravity of the moon by supporting much of the weight of the research vehicle. The vehicle has hydrogen peroxide rocket motors to provide the main thrust and attitude control. The attitude thrusters give the simulator complete mobility within the confines of the cable support system, is applied by 2 support cables to oppose the Earth's gravity and simulate the low gravitational force at the moon's surface. The cables are attached to an overhead hoist and a dolly unit mounted at the top of the gantry structure. As the vehicle moves downrange or cross-range in response to the pilot's controls, the dolly overhead responds to reproduce as nearly as possible a lunar situation in order to study all aspects of rocket-powered lunar flight. After each LEM has been built and tested, its performance capability can be constantly checked right up to the moment of launch. We talked again with Mr. Thomas Kelly in the automatic checkout area.
Apollo 8, Houston, we just got it. You aren't getting it.
Jan Flanagan here. There's something about smoking a late-night cigarette that gets my dick really hard. That's why I pick Midnight Moons. It gets you fucking buzzed. midnight moons. Get fucking buzzed.
Okay, Apollo 8, we have a good picture. We're rolling her. Bill's going to take the camera down the lower equipment bay with Jim. All right. Okay, we're getting a pretty good picture, but if you'd move it a little slower every time you move it around, why it breaks up on the scan. Floating by. Bill's coming up from the lower equipment bay. It's unfortunate that the SOA photo lens doesn't work. Shows lens is the culprit here. This lens doesn't seem to be working. I can't understand why we're not profiting.
If you'd be good enough to bear with me for a little while, I'll see if I can find those papers you want. I rather think they're across the other side of the office.
He was expressing considerable interest in a couple of things that we spoke about the last time we had the opportunity of having a chat. Though, thinking about it seriously...
And though that would be most unlike me, it is, I suppose, a possibility that we can't overlook. So, where does all that leave us?
It leaves us with a tape recording of an experimental link-up between a standard telephone and a unique mobile handset. The mobile unit I was using is no ordinary radio phone. This device is a prototype whose trials are being carried out strictly governed by Home Office regulations. At the moment in the UK, approved mobile phones are really little more than transmitter receivers which put the caller in touch with a post office operator who dials up the number you want and then connects your remote radio extension with the rest of the telephone network. Here is a device which allows you to dial yourself. A dialing tone. And that's quite an achievement because it's one thing to transmit a conversation, it's another to transmit accurate digital information. Now, an extension at the Research Institute in Chelmsford, which has perfected this technique. On the other end of this should be Liz Charnock.
Hello, Liz Charnock.
Hello, Liz. That's a relief to hear your voice. I'm in Danbury Park now. You know the area better than I do. How far am I away from you at the moment? What this combination is achieving is minimising the chances of the telephone network being confused by the number which the radio caller dials in. Each number that goes out from here is transmitted as a series of digital pulses, and each one is preceded by a special digital signal, which tells the receiver back at the exchange that the important digital information is on its way. Excuse me. Hello? Who is this? Well, it's very embarrassing, but the problem is I can't find the piece of paper, as you know.
Thirsty.
different times, all these challenges hit you differently. This one might be harder, the other one might be a bit small, the other one, you never know. Me, I live my life. I live on a day-to-day basis, I wake up today, I say I have today. So I just deal with the day, with each and everything that will come with it. And I guess so far so good.
Pani słyszała coś dziwnego w pracy silnika?
Tak. I ucichło. I tak. No co tak ciężko jedzie, ale straszna mgła, żeby nic, na pewno bym nie wiedzieli, ale taka była mgła, tylko tak dość nie było widać.
Przerywał silnik?
Tak, przerywał.
Neil and Buzz, the President of the United States is in his office now and would like to say a few words to you. Over.
That would be an honor.
Go ahead, Mr. President. This is Houston out.
Hello, Neil and Buzz. I'm talking to you by telephone from the Oval Room at the White House. And this certainly has to be the most historic telephone call
ever made from the White House. I just can't tell you how proud we all are of what you have done. For every American, this has to be the proudest day of our lives. And for people all over the world, I am sure that they too join with Americans in recognizing what an immense feat this is. Because of what you have done, the heavens have become a part of man's world. And as you talk to us from the sea of tranquility, it inspires us to redouble our efforts to bring peace and tranquility to earth.
Thank you, Mr. President.
Jestem kaskaderem. Robię w Hollywoodzie. Mam na to certyfikaty 4.
And thank you very much, and I look forward, all of us look forward to seeing you on the Hornet on Thursday.
Jestem hardcorem.
Look forward to that very much, sir.
SkyCorp presents the hottest new technological advancement of the century, the brain chip.
The brain chip has truly changed my life. I feel happy, secure, and most importantly, a part of the SkyCorp family.
SkyCorp's brain chip is surgically embedded into your cerebellum, allowing you to experience life from a whole new level.
I don't feel anxious, depressed, scared. In fact, I don't feel anything at all. I'm completely free.
The brain chip wirelessly accepts signals directly from the SkyCorp corporate headquarters, leading you to a comfortable, non-threatening life experience.
They even run 24-hour surveillance of my brain at all times. If I so much as think of a product to buy, I'll get non-stop advertisements in my field of vision.
The revolution is here, and that revolution is SkyCorp's brain chip.
Thank you, SkyCorp, for giving me a comfortable life free of worry. Join the SkyCorp family today. Join today. Join today. Join today. Join today.
Thank you, Mr. President. It's a great honor and privilege for us to be here representing
A co no, woda najczęściej, ziemia, woda, coś takiego, nie? Halucynacja, hemoglobina, dwutlenek węgla, taka sytuacja, nie? Nie podoba mi się.
Yesterday, Chandrayaan-3 landed on the south pole of the moon. India did something that no other country has been able to do. None of the superpowers have achieved this feat. In fact, Russia's lunar mission failed just a few days ago, and still it was humble enough to congratulate India on the victory. But is the West sharing that sentiment? You see, not everyone in the West is happy with Chandrayaan-3's success. And we get it. It's bound to sting when a former... Let me read out what he said. I would like to congratulate India on landing on the dark side of the moon. I would also like to invite India to return the 2.3 billion pounds of foreign aid between 2016 and 2021. He goes on to say, I'm quoting further, we should not be giving money to countries with a space program.
With a cow. India is shown as a man with a cow knocking on the door. I'm sure you'll agree that this is racist.
Ever wondered how to pull a demon out of a human host?
Raise it up and Satan.
Get the inside scoop on how it's done with Bernie's groovy exorcisms.
Satan, come out! Let's groove it!
He's the grooviest exorcist around.
Exorcisms are all about having fun. I come to play when the demons are here to stay.
Yeah!
The power of groove compels you.
Now these exorcisms are available for you to learn on Ernie's Groovy Exorcisms.
Eye contact. You don't want him to skull fuck you now. I break it down step by step so you can follow along easily. Or else you'll get possessed.
Come on, John. Let's go.
This demon got me so bad, we had to pull it out of my ass.
Come on, we gotta see it in those
Ernie's Groovy Exorcisms is not sold in any stores.
What is that? These exorcisms are hotter than the flames of hell. They'll make your head spin.
To order, call the number on your screen or log on to demonfunk.com. Must be 18 or older to log on.
And in very poor taste, I'm sure you've seen the cartoon before, including on this show. We've been asking for an updated version. Will the New York Times publish something that is more in tune with reality? We're not holding our breath for a... Chandrayaan-3 is an Indian mission in space. It is the world's first to land on the moon's south pole. This is a fact. This is a fact. This is a fact. This is a fact.
Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour.
Illusion.
Mistyfikacja.
illusion.
Jeszcze wyżej, jeszcze musisz. Nie weszłeś. Nie weszłeś.
Think more smart.